Oké. Wacht nog even een minuutje. Geen probleem. Alright, let's start. Welcome everyone. Welcome to this talk where I'll try to explain to you why I think that serverless is going to be the future of the cloud. Maybe right now or maybe a few years from now. I'll leave that up to you to decide at the end of the session. This is my first time at SDN event, so thank you for having me. I noticed in the other sessions though that you're rather Microsoft oriented, so in that case you can probably consider me as someone coming from the dark side. It doesn't have to hurt, no problems. My name is Bert Edman. I work as a fellow and director of technology outreach at a company called Luminous here in the Netherlands. There's about 150 consultants who do consultancy projects and a little bit of product development as well for our customers, mostly here in the Netherlands, but over the past few years we've been expanding into other territories as well, so we are now also active in the UK and the US. My professional career has revolved around Java for the last 20 to 25 years or so, and so I had the good fortune to start experimenting with Java when it was just about 2 to 3 weeks old, and I've done nothing since. So the good news is that I like to think of myself as that I know a little bit about it. So that's enough of introduction, I guess. Let's talk about the star for the next 50 or so minutes, which is serverless, which I try to introduce using this little diagram over here. So there's been a few talks about serverless already, or at least talks that mention serverless. So there's probably some repeat in some of the messages, but I think there's also another perspective to this talk which I haven't seen in some of the other talks today. So if you think about it, it was not that long ago, maybe 10 to 15 years from now, when we were actually building applications, and when we want to run them in production, we need to deploy them on an actual physical server somewhere, right? If you think about it, 10, 15 years, we were actually doing just that. So we create some logic, we package it up somehow, and then we put it on a physical server, either underneath our desk or in a data center somewhere, maybe in the cellar of your company or maybe in somebody else's cellar. And so I think it was like 10 to 12 years from now, or actually back in the past, when we said, well, let's move on by having these servers get bigger and bigger, so why not run multiple servers or multiple computers on top of a single box of hardware. So what we did was we actually bought bigger boxes, and then we started to run multiple virtual computers on top of a single physical box of hardware. And we call this virtualization, right? Running multiple servers on top of one physical server. And we started to get really good at virtualization at some point, and then we decided to move our virtual servers from our own data center into somebody else's data center, which we then called the cloud. So cloud computing can be seen as a logical next step of virtualization. And cloud computing and virtualization in general has been thriving ever since. So a few years ago, we rediscovered something which we now call containers, which were in the Linux kernel for a long time, right? But we rediscovered them, and I think the popularity of things like Docker have really helped popularizing this thing called containers. And some people think that containers are currently the pinnacle of what we have to offer in terms of virtualization. And, well, honestly, containers are cool, but containers are still a little bit of hassle, right? You still have to deal with packaging everything up, right, and running and orchestrating multiple containers on virtual servers or on physical servers. That doesn't really matter. So, in fact, why not take it like an extra step and create another abstraction, and this is where serverless steps in. Now, serverless got popularized like a few years ago. I think it was at the same time that containers were actually launched. And serverless is actually just another layer of abstraction. And basically what we are running are smaller pieces of code. And some call them functions. So let's ask ourselves why we need such a new paradigm, right? So what's the case for serverless anyway? And I think that what we can say is actually two things. So far the cloud has just been somebody else's computer, right? So it's just virtualization, but then not in our own data center, but at the other end of the internet, which introduced latency and other negative things as well. And the other thing is that, well, we've been talking about servers over the last 15, 20 years or so, and we still have the same notion or the same concept of having to deal with servers, right? So every time we need to run an application, we think of servers first. So servers are what we like to call, well, you can compare them with a pet, for example, or with your wife or husband or child, right? So you care for them, or at least you pretend to, right? You give them a name, or you take care of it, you maintain it, you're attached to it, right? But then you are really upset when they go belly up, right? So I mean in some way we think of servers like pets. Now the fact is, what we really need when we build applications is a little bit of compute to run it on, right? So we should not think of the individual pet, or in this case a cow, if I could to compare it to animals, right? But you should think of servers as like a bunch of cattle which you only use the produce of. So the produce of cows, for example, could be milk or could be meat, and the produce of servers is what we call compute. We need a little bit of compute cycles to run our application on. So every time our application or our function or little piece of application needs to run, it needs a little bit of compute. So we need a little bit of output of servers, and so we rather need to deal with that thing called compute instead of dealing and taking care of servers all day. Now the other thing is that the cloud has been disappointing in terms of all the acronyms over there. So pay-go, which means pay as you go, right? So the cloud promised us back then that we only needed to pay for stuff that we actually were using. But in reality, we were just creating servers on the cloud, and these servers were either on, and then we pay for them, or they were off, but then they were on something like secondary storage or whatever, or we keep them on standby, and then we were still paying for them. And if we turn our servers on, but they do nothing, right, because nobody is using our application, we are still paying for them. So the cloud was not only about pay as you go, but it was rather about pay as you go and also as you don't go, which is an acronym I made up myself. I agree it's not that powerful, but I mean you get what I mean, right? So the cloud is just paying for everything all the time. So there was nothing pay as you go about the cloud as we knew it like a few years ago. So a few years ago, this guy called Werner Vogels, who is the CTO of Amazon, he coined this little catchphrase where he said, no server is easier to manage than no server at all, which is of course absolutely true. And this sparked this whole serverless revolution, which is now really going strong. So let's think about it for a second. Serverless, that's kind of a funny name, right? It actually mostly describes what it's not. So it is not about servers, just as with the term NoSQL, where we say, well, it's a bunch of completely different databases, and the only thing that they have in common is that they don't have a structured query language. So let's call them NoSQL, right? It's like a funny name as well. So serverless is also known by other names. So some people call it functions as a service, or FaaS. Other people, like Gartner, they define it as function PaaS. They say, well, it's like a next evolution of platform as a service, so let's call it function PaaS. And then there's people who like to call it backend as a service, right? And this is a really funny name, right? Because it makes me think of completely other things, right? So I picture myself at this birthday party where people ask me, so what do you do for a living, right? And then then there's this awkward moment where I have to tell them that I repair other people's computers, right? And then they ask you all stupid questions about Windows 95 that are still running. And so right now, if I'm at a birthday party and somebody asks me what I'm doing, I'm going to tell them I'm into backends as a service, right? And then they'll probably avoid me for the rest of the evening, so that's fine. All right, so with every trend or technology revolution that takes itself seriously these days, there is this thing called a manifesto, right, which defines what it's all about. So there's this manifesto for serverless as well. So with serverless, or at least with the serverless programming model, it says that functions are your unit of deployment and scaling, which means that we now will be creating functions as first-class citizens. So we no longer think in applications, but we think in smaller things, like a function, has some input, has some output, and that's about it. And we package that up somehow. Let's say we zip it, right? And we zip it, and that is exactly our unit of deployment. So you create something on your laptop, you zip it up, and you push it into the cloud somewhere, and that's how you deploy functions. Functions are also the unit of scaling, which means that if there's like multiple users coming in who want to call your function, then there will be an instance created of your function for each and every user coming in. So one function is unit of scaling, an instance of the function is how you actually scale. Or you don't have to do it yourself, your cloud provider will do that for you. So this is where serverless actually comes in, right? No machines, no virtual machines, no containers, no servers, no computers whatsoever will be visible in the programming model. So this is geared towards developers. So developers will not have to deal with servers anymore. Of course, little spoiler alert, there are still servers involved, but it's the cloud provider or the man behind the curtain, if you will, that will take care of actually running these servers for you. And depending on what cloud provider you use, you will either get some form of virtualization underneath, or it will be based on containers. But you will never see them and you can't touch them. Serverless is a stateless programming model, meaning that you can't keep state inside of a function in between requests. Right? So you can have some state in terms of somebody can put some input into your function, you can do something interesting with it. But if you want to keep that state somewhere, you have to store it in what they call secondary storage. But there's still middleware in serverless, so there's still databases and caches and what have you. So it's perfectly fine to connect from a function to a database and then store your state there. And if you need that state in another request, you go back to the database and you fetch it from the database. Functions scale per request. We already talked about it when we talked about the unit of scaling in the first bullet. But scaling per request also means it has this nice benefit that we now can no longer over or under provision capacity. So imagine you run this web shop, right, where you have like 1 or 2 times per year you run this big promotion. For example, your Christmas sale or your Black Friday sale or what have you. Now, in order to scale for that, you need to scale for peak load, right? You need to make sure that whenever the peak load hits, your server is still responsive and your functionality is still going to respond in a timely manner to the incoming requests. So if you scale for the peak load, that's how we usually do it, right? Then you pay a lot for all of those servers doing nothing for the rest of the year, right? So you are over provisioned. It gets worse if you're under provisioned, because in that case, if the peak loads hits, then your service will be completely stalled and they can't reply to incoming requests anymore. So you have to deal with the actual scaling, and this is hard, right? This is non-functional requirements, you have to think about it, you have to do a little bit of calculation, try stuff out, etc. So this is bothering you, and this is also keeping the focus away from actually writing code, right? So with serverless, the cloud provider takes care for you, right? So when a request comes in, when it's just a single request, you just have a single instance of your function running. But if there's like 1,000 requests coming in at the same time, then it's up to the cloud provider to make multiple instances of that function. And if it can't run it on the underlying piece of hardware or virtual hardware, or whatever, it needs to make sure to scale up for you automatically. So the elastic up and down scaling is being taken care of for you by the cloud provider. You don't have to worry about it. So you get auto scaling and elastic scaling for free, basically. You don't even have to think about it. So it's true pay as you go, which means that if I create a function, upload it into the cloud, and nobody ever touches it, I will never pay anything for it. So when my function is at rest, I will not pay for it. I only pay for the function when it's actually running. There's like a really tiny fee that I have to pay for running a single instance, and that adds up over time, of course. And then the cloud provider will bill me for only the compute cycles which were actually used for running functions, and that's about it. So you never pay for idle. It's implicitly fault tolerant, which is also a nice side effect of scaling per request, which means that if one user does something which breaks the function because the underlying hardware is having a failure or whatever, then it's up to the cloud provider to route the next incoming request to a new instance of that function running on a different piece of hardware somewhere, right? So the cloud provider takes care of fault tolerancy too. right? So with multiple incoming requests, it will route new requests to a new instance of that running function. And the functions can be running all over the place. It's up to the cloud provider how they do it. Functions are all about bringing your own code, which means that you do some offline code editing, or there's also nice editors which can run from the cloud, right, completely in your browsers. So you bring your programming language and the functionality of your choice, you just zip it and then you upload it into the cloud. That's basically how it goes. And then finally, last bullet, metrics and logging are a universal right, meaning that every cloud provider offering you a functions platform needs to take care of centralized logging, right? So if you write something to standard out, or you do some logging using a logging framework, then the cloud provider will gather all those logs for you in a centralized place and will give you access to that log. And the same thing goes for metrics. So the cloud provider has to provide you some basic metrics of how many requests are being handled by your functions, and a bunch of other basic metrics too. I will show them to you when we do some demos later on. So summarizing this into benefits, it seems that as developers we now no longer need to care about servers. So we have no pets, no servers to attend to, right? So that's cool. We only pay for when we actually execute something. We never pay for idle, so that's cool too. And we get the automatic scaling and the automatic failover, which is also very cool, because now we can just concentrate on writing a useful piece of logic and everything else is being taken care of. So in other words, if you come from the world of Java, from .NET, you no longer have to care about web servers or application servers, and you also no longer have to care about containers. So containers are something from the past, believe me, right? It's what cloud providers run, it's not what you should run. So far, sounds pretty decent. Okay. Alright, so let's take a look at some of the offerings out there. There's a bunch of offerings. I just listed the big four in terms of the cloud providers. It was AWS Lambda that really sparked this when Werner Vogels did the quote back in 2014, I believe, which is about 3.5 years ago. And so AWS has been running Lambda since late 2014, has been quite experimental in the first year, but I think over the last 1.5, 2 years it has become really useful, and we see lots and lots of uptake in the AWS Lambda space. So there's lots of innovation happening there, and there's actually a lot of Lambdas running in Amazon's cloud right now. As you can see, the other vendors have been playing catch up ever since. So we see Google stepping in, we see Microsoft stepping in and chasing after Amazon, and we also see IBM stepping in, although I think their cloud share is just marginal. It's just their own customers that run this, and their public cloud offering is not that popular. There's of course another very big vendor out there, which is Alibaba. Right? They have a similar model to Amazon, but I couldn't really find anything about their functions offering. They probably have it, but my Chinese is not that good, so I gave up on it. Alright, so for the remainder of this talk I'd like to focus on Lambda for a bit, because it's the function platform that I know best. You've seen a lot of Azure probably already today, or you will in the next talk right after this. So let's give you a little bit of another perspective and show you a little bit about Lambda. And I also think that Lambda is currently still ahead of the pack in terms of features and what they have to offer. But like I said, the other cloud vendors are rapidly catching up. So this was introduced November 2014. It's a platform that runs code in response to events, which is already a little bit different to how Microsoft does it. So events are like a big thing. We'll talk about it later on. And then Lambda will just offer you all the compute resources that you need in order to run your function. And it's part of the many offerings that AWS has. They have over 100 services running in the cloud, and this is just one of them. It has runtime support for these basic 4 languages, and they recently added Go as well. So as you can see, there's like maybe 2 real languages, Java and C#, and then a bunch of other stuff. Yeah, let me get back on the languages aspect when we do some more demos, because there are some important differences between running it in Java or C# or whatever, or in Node, for example. So maybe I should just show you how to create a Lambda function, because then you get a better picture of what we actually need. Now for this, instead of showing you C# code, I'm going to actually do it in Java. But don't worry, this will be just a few lines of Java, and if you know anything about C# or JavaScript, then you will be able to follow along just fine. So this is Eclipse. This is just my Java editor of choice. Could use something else. The fact that I chose Eclipse is because they have a really nice AWS plugin for it. But if you like to use IntelliJ or Visual Studio Code or whatever, you can do it as well. So let me start by creating a Lambda Java project, which just takes me through a wizard. Let's call it SDN. And I'll leave most of the defaults. It's going to create a function handler for me. And I will just use a custom input, so I just get an object which is easy to cast. So for now I just take this. Let's run through the wizard. It creates this readme with all the steps that I can take in order to create my function, upload it, and then run it. So let's get rid of it for now. And here is some really basic function handler. As you can see, it's just a function, just one method. Takes some input, takes an object as input over here, and then it has some output in this case it's going to be some string. So let's do a hello world, right? Let's do a basic hello world thingy over here. So no fancy code, so everybody is able to follow along. I just take the input and say hello and then somebody's name, right? This is your basic hello world example. So I'm going to save it. And now the nice thing about this plugin is that it also generates unit test skeletons for me. So in this case I can just open up a unit test, right? Define the input for this. So let's call it SDN over here. And then quickly do a dirty little unit test over here. Right? Just check it, save this, and then run the unit test. Here we go. And we get green bar, right? So that's encouraging already. So functions are just small items, so they're ideal to unit test, right? If you just write some logic, this is ideal to unit tests. You can just do input tests and do some branch testing and whatever. Okay, so now I can run it locally like I did with the unit test, but I want to of course run it in the cloud. So in that case I'm just going to use the wizard again, and I'm going to say, well, run this function on AWS Lambda. So it says, well, if you want to run it, you need to upload it first. So I say, let's upload. What it does now, it creates a little zip file underneath, right, where it just zips up all my items into this zip file, and then I need to basically tell it where to deploy it. So in this case I'm going to select the AWS region. So my stuff runs in Ireland, EU West 1, and I give it a name. So let's call it my SDN function. Press next. Right. Give it this nice fitting description over here. And then it needs a execution role. Everything in AWS needs execution rights, right? Because there's so many services requesting services from other services. You need to have the correct set of rights in order to be able to use all of those services. So for this I use the most basic role, which is a Lambda basic execution role. Nothing special, just enough rights in order to invoke this function. And then I need to define the bucket where this zip file can be uploaded. So this is going into S3, which is the blob store of Amazon. And basically it will just place the zip file in a bucket somewhere. So Amazon can then use that zip file to run my function out of. And then I can tune the memory settings a little bit. Now you can say, hey, what about serverless and tuning memory? Well, this is actually the amount of memory and the amount of runtime that I allow is being reflected in my bill. So if I tune down the memory, so for hello world, I think 128 megabytes of memory is more than enough, right? I pay less because you pay by the memory you use per 100 milliseconds. And then the maximum amount of runtime here, I can limit that to just 2 seconds, for example. And this is the maximum amount that this function is allowed to run. If it runs any longer, the runtime will just kill it off. So this is also to guard yourself against a high bill, or if something goes really wrong inside this function, you can just shut it down automatically after this timeout. So we're not dealing with servers, but we're tuning the settings for this particular function to run. So press finish now. Now it's uploading, depending on the network speed. That might take a little bit. There's a few megabytes which will be sent into the AWS cloud. Oh, there we go. So now it's running in AWS somewhere. So I can now invoke it again by saying run this function on AWS Lambda. I can then give it some input and press invoke. As you can see in the log in the bottom part of the screen, right? It's invoking the function, sending the input into AWS. This is the return, and then there's some basic metrics being output here. So we see that it took about 218 milliseconds to run this, including the network round trip, and that the build duration is going to be 300 milliseconds. So this means that this is being rounded up to the next 100 milliseconds, and that is the amount of time that you are being billed for. And this along with the memory size. So I gave it a max memory size of 128. It only used 42 because it's loading all kind of class libraries, etc. And so 128 is more than enough for this function. Now the funny part is, what happens if I run it again? Right, so let's do it again. Run function. Let's give it the same input, that's fine. Invoke it again. And now you see it only takes 0.78 milliseconds, which will also be rounded up to the nearest 100 milliseconds. So apparently there's some caching going on behind the screen. So it's keeping this function hot. That's the terminology that AWS uses. Right? And from my experience, I found that it's keeping the function hot for between 30 minutes to 50 minutes. It's keeping the same function hot. So, and that might be useful because if you do a lot of initialization in your function or static resources that you configure for this particular class, then you don't have to do that again as long as the function is hot, because it's static, right? So it's per class. So it's shared by all the function instances. And so you can optimize for this. You should be careful with optimizing for the Lambda runtime. But if you decide to optimize for this, you can create like a trigger which just calls into your function every 35 or 40 minutes to make sure this function instance stays hot, that you get the low response times. If it somehow goes out of the cache, if the instance gets recycled by AWS, you pay this penalty of this 200 something milliseconds again. And this is because Java, just like C#, is interpreted language, so it needs to create the runtime, spin up a container, create the runtime, deploy our class files or our function on top of it, and that is the 200 millisecond or something overhead that we saw with the first request. You don't have that if you use Python or Node.js for that matter, right? Because they don't have this model that C# and Java have. They are just interpreted on the fly, and therefore you don't pay this penalty. So language choice can be important if you want to keep the spin-up time really short, right? But as you can see, if you hit the same function again, it's under a millisecond. So there's the penalty is just once every so many minutes. But it might be something to consider, depending on the use case for your functions. Now let me switch to the other end of the internet. This is the Lambda console. Here we go. This is the Lambda console. So if you log into AWS, this is the console that you see for Lambda. You can see some basic metrics already going on because I've been running some stuff on AWS Lambda. So if I scroll up, I can go to my functions dashboard, and there's a bunch of functions here, and one of them is the function that we just created. And as you can see, so here's the function, here's the basic rights that we assigned on the right hand side. So we have access to the logs, which I will show you in a minute. And if we scroll down, there are some minimal settings that you can do, and one of them is the description and tuning the memory size and the timeout, which we just discussed, right? Just very basic stuff, so you don't see servers or VMs in this model. And you can see that it's just a zip file that we can upload in order, which holds our function code. And you can see the different runtimes which are being supported by AWS. Now let's talk about these logs for a second. So if I scroll up, there's this other tab called monitoring over here. You see some basic metrics for this particular function. Not really exciting yet. And we can jump to the logs. So we invoked so some basic log gathering and some basic metric information. And that's about it. So let's switch back to slides for a second. Now, like I said, events play a big role in the life of Lambda functions, right? Because as Amazon sees it, Lambda functions are event driven. So you need an event in order to trigger a Lambda function. So Amazon has many event sources, and if you're familiar in the Amazon landscape, you probably know what all these terms mean. If you're not familiar with all these terms, I try to translate them for you. So basically, there's many ways to interact with the Lambda functions. For example, you can send it some HTTP requests, get, put, post, delete, whatever, right? But it can also be triggered by CRUD events on data sources. So you take one of the many data sources that Amazon has, and then whenever somebody does an insert or a delete or whatever operation on the data source, that operation can then trigger a Lambda function, which gets the event which caused it to trigger as input. So you can do something with a file before somebody can delete it, right? You can also use queuing mechanisms or messaging mechanisms as a event source. In this case, it could be some message queuing kind of service, or it could also be just a simple email, right? So if somebody sends an email to a service account, then that email could trigger a Lambda function, which will then parse the contents of the email and do something useful. And then there's other hooks, like you can see on the right-hand side. Stream-based processing is also really cool. So you can hook it up to a service called Kinesis, and Kinesis can be hooked up, for example, to, I don't know, the Twitter Firehose maybe. So that's like the real-time tweets that go on. So Kinesis can then filter this huge amount of tweets coming by, and if there's like a filter which traps a certain tweet because you want to do sentiment analysis on a product type or on something which is happening right now, then it will just take those tweets which will be filtered from the stream, and then they will just fire up a Lambda function which can then do something useful with the content of that particular tweet. Right, so that's a really nice way of invoking Lambda functions, for example. Amazon also has their own in-cloud build system, source control system, whatever. So what people are using Lambda a lot for is to build custom pipelines for checking something out from Git, or when somebody does a push to Git, that will automatically trigger a build or set permissions or do a automatic deployment by downloading the build artifact, spinning up some images, and then throwing the build artifact on top of a server somewhere, right? So you can use Lambda as some kind of glue services to do something useful to other Amazon services. And then hook it up to Amazon Configuration Management, and finally you can interact with services like voice and text. And if you have enough time, I can do a demo with that too. So let's step back a little bit and let's see if this serverless thing can actually replace our traditional way of developing applications, right? Just for the fun of it. So when I think of a traditional application today, then what we mostly are doing is developing web applications, right? So we have some form of a interaction with the application, mostly through the browser, could also be through an app on your phone or tablet, whatever, but mostly through the browser. And then we have some interaction with the backend that runs some logic, maybe even generates HTML. It really matters on the framework that you use. And then if it needs to store something interesting, it uses a database. Right, so this is our traditional way of developing web applications. So can we entirely replace this with serverless technology? Well, the answer is yes, of course, otherwise I wouldn't be talking to you about it. But as you can see, the architectural diagrams becomes a little bit more cluttered and complicated. But let me talk you through how a full serverless solution would look like, right? So first off, we need to have some place where we can serve our static web content from. Normally you would have a web server set up, which will then serve you HTML files or static compiled files from a single page application or whatever. So in this case we don't have a web application, a web server. So what we could do is we could use a CDN server from one of the cloud providers or a commercial one out there, place our static content over there, a content delivery network, and then your browser via domain name resolution can go to the CDN, download all your static files, and that is the way in order to get the UI for your application. If we're not building a website, we can also use a app store in order to interact with our backend, right? So you can just create an application for the iPhone, put it in the Apple Store, or for Google, put it in the Play Store, whatever, and the user downloads your application. This is the way to distribute the user interface. In both cases, it's a serverless solution. We don't take care of the servers running underneath, we just place the content there. Then, the second step that we need to do is we need to come up with something that handles authentication for us. So typically on the web, we use something like OAuth, which then integrates with some security system somewhere and makes sure that we can identify our users and that they have the correct rights in order to invoke some of the pieces of our application. Now there's many services out there providing these kind of services. Could be from the same cloud provider, could be from a third party, but they're well known and easy to integrate in modern web applications. Then we need to think of a way in order to get some content into our user interface. So if I'm running an Angular application here, for example, and I want to list some product catalog, I need to get data from somewhere. Now most of the cloud providers have database offerings out there, and these database offerings, they can be marked, for example, as read-only, right? And you can expose them directly through some maybe REST style interface to browsers on the internet. So in this case, our Angular application can go to this database, which has this read-only product catalog here exposed to REST services, and that is how we are retrieving our data for our application. Right. Once again, serverless offering, we are not taking care of running the database, we just put the data there. Then there needs to be some logic about how to move from page to page to page. Right? This used to be in the backend, where we did this model view controller thing on the backend. But nowadays, with single page applications and running more and more JavaScript and frameworks in the browser, we can leave that up to the browser. So the browser and the frameworks running inside it, they know how to move from page to page. Actually, all of the model view controller, or whatever we're calling it these days, are now in the browser. Right? So all the navigational stuff, all the controller stuff is being handled by the browser. Then finally, there's going to be some logic which will be exposed on the backend, but we are not allowing just everyone's browser to interact with our business logic directly, so there must be something in between. And most cloud providers these days offer you something like an API gateway, which can be used to expose interfaces, for example REST interfaces on the left hand side, and then you can map those REST operations onto functions on the right hand side. Right? An API gateway is what we used to call an ESB like a few years back. Right? So all of the vendors rebranded their ESB offerings into API gateway, so they can sell you the same shit, but then again. So then we have our backend functionality. Let's say we have this really complicated search function which we somehow don't want to expose as JavaScript in the browser directly. So this is being exposed through an API gateway, so somebody does a get or a post to something over here, which will then be mapped to this search function, which then interacts maybe with the same catalog or with something else. Then it returns the result as the result of this get or post operation. And this is where, in this case, Lambdas come in, or if you run this on Azure, where your Azure functions come in, or on Google, whatever. And then there could be more, like purchase functions, for example, and then eventually when you interact with credit card and payment stuff and orders, right, you want to store something into a database which is not accessible from the client browser, but which you use for your internal purposes. So the answer is longer, right? It's yes, we can do all of this with serverless technology these days, but just because you can might not always be the right reason, right? So don't run off back to work Monday and start replacing all of your applications with serverless technology just yet, right? It might not be the best solution for every problem. However, there is a bunch of interesting scenarios where I think that serverless is already very, very useful. So let me talk you through some of these scenarios. I'm doing on time. So one of those scenarios is a scenario like this. Imagine we're a startup and we are launching a new service into the market, and in order to use our service you need to sign up and create a profile. Now, creating a profile means you fill in some personal details and then you use your phone, take a picture of yourself, and you need to upload this profile picture, right? Now, phone camera these days creates photos of 4 or 5 megabytes, right? Which is far too big for a small web profile thingy. So we just upload that raw photo, this 4 or 5 megabyte of photo. We upload that through our application, could be an app, could be a website. We upload that into some blob store, in this case S3 bucket, and then we define a CRUD event. So whenever somebody inserts something in this bucket, that will trigger a Lambda function, which will take the input image and then convert it into a thumbnail, 100 by 100 pixels, and will then save that into another S3 bucket, which will from then on be used as your profile picture. Now, why would I build this as Lambdas? Well, not because it's cool, but because if I build this into my regular web application and our service gets popular because we go viral somehow and we have like 1 million signups in the next hour, that is where most startups kill themselves, right? Because they're not able to handle the scale. They're not able to, well, they don't have enough money to scale up. So, and when things get slow and people can't sign up, or you have poor user experience, this is where people say, well, this service is really shitty, I'll try something else, right? So by not running this in our regular service offering in a traditional application, we are not cluttering the functionality of our application with just signups. And especially in the beginning, or when we get discovered, these signups can get really out of hand. So if you have 1 million signups over the next hour, and we put it in a serverless solution, then the cloud provider will take care of the scaling. Yes, we pay for it, but it's a small amount of money. And we just keep this little piece of functionality, which could just throw our server on its back. We just keep it out of the regular service offering. So this is a very good scenario for having serverless because of the auto-scaling and the automatic provisioning and the automatic failover. Alright, so I won't show you the implementation, but I want to show you how this works in action. Right, so let me take the chair. So this is the S3 management console. So this is the blob store interface. And I have a few buckets over here, and one of the buckets is the incoming file for Lambda. It's currently empty. I can refresh it, so there's no files. So let's imagine somebody is creating a profile, and now he wants to upload a picture. So we do add file, we go to the desktop, and probably something on desktop. Here we have it. So this is my profile picture. It's about 2000 by 2000 pixels. It's half a megabyte big, but it's way too big for a thumbnail, right? So I just open this one, upload it into S3. It's already there. And now we wait for a little while, because uploading it will trigger a Lambda function, because it triggers on the insert. And it's the cloud, right? So it's eventually consistent. So I need to help it a little bit. All right, there we go. So bucket is empty, which is an encouraging sign, because it had probably been picked up by the Lambda. So now we can go to the processed image thumbnails folder, and you can see that it just created this thumbnail file of the same image, and I can open it. It's now a tiny image of 100 by 100 pixels. Right? This is just maybe like 15 lines of Java or C# code in order to get this done. Just a little bit of image I/O magic that you do, reading a file, converting it into something else, and writing it back to another bucket. And this is an ideal scenario for running Lambda functions, or for running Azure functions actually. So what else do we have? Well, you can say, well, triggering something when something happens to a database. Haven't we seen that before, right? This is just database triggers all over again, and we know where that went, right? So the answer is yes. This can become messy and hairy pretty quickly if you have triggers all over the place, which will then trigger something else, which triggers something else. It's really hard to get an overview of what is happening. So you should use this with care, right? Don't put them like everywhere, but only put them in useful places. Think about the scenario where you're actually using this. So let's look at another example. Right? Let's go back to this whole backend as a service thing, because it's cool, and as you can see, this is a heavily used backend over there. So another scenario which is really interesting is, let's imagine we're app developers, right? As app developers, we know all about creating iOS applications with Swift, or we know all about creating Android applications with Java or Kotlin or whatever is hot these days. But we're not so much into setting up a backend because we have to learn how Heroku works, or we have to learn how Google App Engine works, or we have to learn the specific Microsoft or Amazon offering for this, right? And this is just hassle, right? We need to learn new APIs, we need to be able to set up web servers and configure them and take care of them. So it will be really easy that if we have some pieces of backend functionality, that we can just write the code, maybe in the language that we like already, and then put them as functions in the cloud somewhere, which will then only be triggered and only be paid for when somebody's actually using it. That's exactly my next demo scenario. So here we have either a mobile app or a web application again. We have a Lambda function doing something useful, and then we put an API gateway in between, which handles get, put, post, whatever, right? So we can create a versioned schema on the left hand side, a versioned API, and we can handle stuff like API keys and throttling and what have you. And then on the right hand side we just have one or more Lambda functions interacting with backend services, for example databases. So for this I have a small demo too. Unfortunately I think it's in, I know for sure it's in Dutch, but not that hard to follow along. So I'll translate along the way. So you can see that I'm not really into user interfaces, right? I'm a developer, and developers have this thing, well they have, or at least I have the luxury of a company car. And the trouble with company cars is that, you know, when you just get it, you are really satisfied with it, but then after a few months you just want the next one, right? Or at least that's what I want. So I have this thing called the lease time calculator. So I just got a new company car just about a month ago. So this is the start of my contract. Then my contract lasts for 48 months, or unless if I hit the maximum amount of mileage first. In this case it's 140k. So now I'm going to put in my actual mileage, and then it will calculate for me if I will hit the 140k first or if I will hit the 48 months first, right? So I can just calculate when my lease contract terminates, when I can start looking for a new car. That's basically what this does. So I think actual mileage is about 3,000k. So let's check, and then we get something back from the backend. So it says, well, your contract starts 2018, it's supposed to end 2022. You are now 3% in. The amount of kilometers to drive on a given day is 95 on average. You only did 81, so unfortunately no, you have to serve the entire 48 months, right? So I need to step it up in order to get a new car. That's basically what this does. So let's say this is a killer mobile app, right? I'm about to release it in the stores. But if people start to hit this app, right, then my backend logic is just a Lambda function in this case, which will only be triggered when somebody's actually using the app every now and then. So I only pay cents, maybe nothing even, because there's a large free tier with Amazon. The first 1 million requests per month are for free, so I'll probably never get over that tier. So basically my backend logic is for free, and I don't have to take care of servers, which would be entirely different if I would run this on Google's offering, or if I would run this on Heroku, because then I was paying for web servers, and I was scaling web servers, and I was applying patches to web servers, and this is taking a lot of time, which I can also use for creating more of these killer applications like this one. So let's get back to slides. So then there's other use cases. I already mentioned this, but a lot of people are using Lambda functions on Amazon actually as some kind of glue logic in between other services of Amazon, or for build pipelines, for CI/CD stuff, like I mentioned here. And then there's like the newer services that all of the cool cloud providers are offering, where you can play around with bots and voice control, and maybe you recognize the device. It's an Echo device there, which is Amazon's voice assistant, and I already set one up over here. So we can also interact through the voice assistant with our Lambda function. This is also a pretty neat feature, because if you think about it, just like thinking in terms of servers is an old idea, the whole idea of inputting stuff in computers by just using a mouse and a keyboard, that's also a very old-fashioned idea, right? So why not use our voice in order to interact with some logic? In this case, interact with logic running on the back end. So what I did is I created some Lambda function, that is going to be triggered by my voice. So I can talk to the device. I just give it a command. The command corresponds to something which is called a skill. And a skill is basically interpreting whatever I'm saying and then triggering functionality in the backend. So in this case, I just have a tiny hello world thing set up. So I just give it a command. Then the skill will translate that command into an invocation of a function. So let's see if it works. So I say, Alexa, ask demo to say hi.
Hello everyone at SDN. I hope you are doing okay and that you like Bert's serverless talk. Have a great day.
Right, so it's very easy to build something which just, well, takes an input event and then does something interesting and responds to the same interface. So in this case, this is just like a hello world function, just has like a fixed message which it will return, and the event to trigger it is being done through the skill interpretation. So I can just set up the command. Well, actually I can show it to you how I actually do it. It's just translating a command. So let me go to the skills kit. Here it is. This is my hello world intent. That's what the skill is actually called. So I just define a few phrases which I can say, right? And then it's going to translate that into an invocation of a function running underneath. And this function is actually tied into a Lambda function. And the Lambda function is, well, I can quickly show it. It's called a speechlet, so it has a little bit of a different interface. But basically, it's like a servlet in Java. So it has these on this and on that methods. So I can basically start an interaction through the device with the skill, and then I can respond just in code to certain operations, right? So here's my response, which Alexa has just delivered to you. It's just a matter of setting the text and returning it onto a speech output. That's basically what I'm doing. And then there's just a tiny bit of Lambda code which is actually gluing this together, which is the handler over here. This is how I map it to the skill, and then here I'm just invoking the speechlet, and that's about it. So it's really easy to start interacting with voice. Right? This is a very simple one, just one command, one answer, but I can also create a so-called session. In that case, the app gets into a conversation with you. So you give it a command, asks you a question, you answer, you get a next question, you answer. This is how you can play games with the device, for example. Alright. So most of the examples that I've been showing were pretty basic, just very simple stuff just to illustrate what you can do with this kind of technology. Now there's also documented cases of companies running this stuff at scale, and one of them is Expedia. Now I take that you know what Expedia actually is, right? It's like this Google for hotels, flights, car rentals, whatever. It's like a big search bar. You type the name of a hotel or city or whatever, and then they come up with search results. Now they have been replacing parts of their data center with a Lambda function. So instead of running everything as traditional applications, they have been rebuilding parts with serverless functionality. As you can see from the numbers, these are actually staggering, right? This is 2.3 billion computations per month, which comes down to over 200k compute hours. So if you do a little bit of calculation, there's about 5,000 hours in 1 month, right? So this means that there's about 40 to 50 computers running each month, 100% CPU, actually delivering you compute, right? So that in reality there will be much more computers, but because they are not all running at 100% CPU. But this is like hundreds of computers delivering you horsepower every month, and this is their bill at the end of the month, right? So that's $550. Now they probably get a little bit of a discount because this is a nice use case for Amazon, but still, if it was like double the amount of money, right? If you compare that to running half a data center or even more, the cost of running half a data center each month will probably be a little bit higher, right? So you can see that there is a huge amount of cost savings in just using a pay-as-you-go model. Disclaimer here is that of course they only replace the functions which actually benefited from this pay-as-you-go model, right? You can probably think of applications which do not exactly pay from or have benefits from this pay-as-you-go model because they need to be always on or whatever. So not every use case will translate just as much as this one. But in this case, you can see the huge benefits and the huge cost savings that in this case Expedia has. So yeah, once again, cats riding unicorns. It's all sounds too perfect. So very cool stuff. But we have to think of some of the drawbacks of serverless too, because right now there's a lot of sharp edges. So I just listed a couple of them. So first off, serverless sounds like something which is generic and across all vendors, but in reality it's something which is really vendor specific, right? So the manifesto which you just been showing to you, well, that's probably true for both Microsoft and Amazon and for IBM and for whoever, but then if you start using their APIs, if you start using their services, and you will, because you will be triggering services from these Lambda functions or from these Azure functions, then you are getting more and more into the realm of vendor lock-in, right? Because these APIs are all very proprietary, and so you tie into the vendor more and more and more. So if you build everything in Lambda functions, you will eventually be very tied into the Amazon platform. Now that could be a problem. It could also be perfect for you because you have bet all your money on Amazon, right? So it depends on your use case, but it has to be a conscious decision that you need to take. Multi-tenancy is also something which is not really handled well by serverless right now. Multi-tenancy means that if you want to have the same function for all of your different customers, right? So maybe you want to differentiate between your different customers. So customer A can only see part of the data which is in your database, and it can definitely not see the data from a company B, right? In that case, you need to handle multi-tenancy yourself. So that's not something which is really hard to do, but there's no like general solution for this. So you have to think of one yourself, which means passing on IDs or setting filters on data or whatever, but you need to handle it yourself. Then some people have security concerns with serverless functions, because they say, well, instead of having just like a monolithic application with a clearly defined access point to some of the logic which can be accessed from outside, in this case we have all sorts of smaller pieces of logic which will then all be opened up to the outside world. So in other terms, we are increasing the attack surface for hackers, right? They have more entry points in order to get into our backend. Well, the thing is, with Amazon, it is you are not able to invoke a Lambda directly, so there is always an API gateway or something else in between. So on this service we can handle security. We can do stuff like sign-ins or sign-ons. We can check for headers, we can check for API keys, etc., etc. We can do throttling, but you have to think about it and you have to enable those features, right? So on other platforms you are able to directly invoke Lambda functions or expose HTTP endpoints directly from your functionality, and in that case you really have to think about your authorization model and your authentication model in order for outsiders to access your core logic. So yeah, there are security concerns. It's not that you can't handle them, but once again, it needs attention. You need to think about it, and you need to come up with the right solutions. Then, code that needs specific server optimization should not be run as serverless functions, because you have no clue what is actually running underneath. It could be a big processor, it could be a small one, it could be many processors, could be a single one, could be lots of memory, could be just little memory. You have no clue. So if you want to do Bitcoin mining, then Lambda functions are probably not your first choice, right? In that case, I would use one of the big ass GPU servers from Amazon, and then I would use a Lambda to control that server. So I would trigger the Lambda to fire up a GPU server, then do my mining stuff, and if I'm done, I use this. I use another Lambda to just kill off the GPU instance. So I use the Lambda as a glue code to manage the environment, but I'm not doing the actual mining or the big ass processing in the Lambda function, because my execution time is limited to 15 seconds, right? And I have no clue what's running underneath. Could be just a small processor. Then with Java and C# we see some of startup latency that we already talked about. We don't see that with Node.js and Python or with Go. So depending on your use case, it's probably better to use JavaScript over Java or C# over whatever. It determines on the use case that you have. Limited support for testing still. Amazon is not really keen on running all of Amazon Cloud on your local laptop. I see that Microsoft has definitely beaten them there, right? With the local testing frameworks that you have, which you can run, which you can test your services or your functions on your laptop. Then Microsoft is already passing Amazon there. Although Amazon is working on something which is called SAM Local, which is like a local mock of some of their services, but they could do better. So for integration testing, it's still hard to do. In fact, the best place to do integration testing is actually in production. And they do have good support for that, so you could have multiple versions of the same Lambda functions. And they can also do A/B testing using Lambda functions. So as soon as they notice that something goes wrong, they automatically switch all of the traffic, all of the incoming traffic to another version of your Lambda, and you can do load balancing between them. So that's actually very advanced stuff. But local testing, that's still something that they need to work on. And then finally, discovery of Lambda services. I just had a small list of 10 different services if you paid attention, right? So that's just manageable. But let's say that there were like 500 of them, then it's really hard to keep track of what every service is actually doing. So in that case, it comes down to process. So it comes down to doing DevOps and stuff. So you have teams which are fully in control for the pieces of functionality that they created and that they own and that they run. So in that case, a team is in control of just their services. But if you use the web console in order to keep track of your services, it's going to be really, really hard because it's just one list with no hierarchy of all the functions that you have, right? So that's basically becoming unmanageable really, really quickly. So you have to think about that and come up with a solution in terms of process. And Lambda functions also have no way of discovering other Lambda functions. So you can't call a Lambda function directly from another language Lambda function. So if you want to do something like that, it needs like a message queue in between or something else. Alright, I think we're exactly out of time. So here's a little summary. Leave it to read for yourself. I think it's cool stuff. Lots and lots of innovation is still happening in this space, so we see more cool stuff coming out in the next couple of years. It's definitely usable right now. Has some quirks, has some sharp edges, so depending on your use case, could be interesting to explore and experiment with. And so I think it's the future of the cloud, but I'll leave it entirely up to you. Thank you.